Hey, in this video, we're looking at how to use assertions or assert statements in the C++ language. Assertions give us a very simple way of catching errors in programs, and these assert statements have been really around forever, since the C language in the 70s. We have them in C++, they're in Java, they're in C#, they're in other languages. For me, they're really an essential part of my programming practice. Assert statements are going to be all through all the code that I personally write. Now, for my students at CUNY Kingsborough, they're probably not seeing them until our data structures course at the sophomore level. And I really wish that we had time to present it in an earlier course, but better late than never. So using asserts will really make some of our development practices a lot easier and a lot more secure. We should use them. Let's see what that looks like. So here is a minimal demonstration of what assert statements do, a little bit of code on screen. First of all, on line 9, I'm including the C assert header file. That's where asserts are defined. And that's called C assert for what it's worth, because we're just inheriting this from the old C language, and it still works the same way as it always has. So what I'm modeling in this main function is getting into a function that has some kind of precondition, like the function only works on positive integers, only works on positives. So I'm going to test that here with some kind of incoming value, and then if my precondition is only work on positives, line 14 is my assert statement. Kind of looks like a normal function call. So I'm asserting that value should be positive, should be greater than 0 at this point. If that's the case, then we'll continue on with the rest of the body of the function. And in this case, I'm just going to print out a message. The value is whatever number you're looking at. So if I compile this and I run this little test case, so obviously val is 42. You get to line 14. I assert that it's positive. It really is. You just continue on with the rest of the program, and it does get to line 15, and it prints out the value is 42. If I change to other positive numbers coming in, obviously the same thing is going to happen. So here, value is 5. I assert that it's positive. It's true. You continue. You print it out. But if something winds up happening and you come in to the function with a negative number, which is not supposed to happen, what does that look like? Okay, so I come in with a -8. I get to line 14, I assert that it's positive, but that's not true. And what the assert statement does is it just kills the program at that point. And you do get this message on screen. It says, hey, there's an assertion that failed. Remember, the whole point of assertions is they're supposed to be always true. So if an assertion fails, it says specifically what failed, the fact that value is supposed to be greater than 0, that failed. And it tells me specifically what file and what line the failure was. And obviously in this case, it's in this assert test.cpp that we're looking at, specifically on line 14. Notice that we never got to line 15. There's no printing of value is or anything like that. The program just stopped dead as soon as you run into a false assert, and nothing else happens. We get a non-zero return value from the program. And that's what asserts do. So frequently in my code, how you use these is they're peppered all through all your functions. Right at the start of a function, there's an assert statement that checks in that the preconditions are true. Right at the end of a function, there may be an assert statement that the post condition is true. And so if at any point you make some kind of mistake in your program, one of the asserts will immediately catch it and tell you there's a problem, and specifically tell you where the problem is before you start developing your program to a larger degree and run into trouble that you have trouble tracking down later on. So these can be your guides potentially, maybe in every single function you write. And as soon as you make some kind of little logic error, it'll probably tell you exactly where it is. Now, here's a thing you probably haven't paid attention to before. The top right of our IDE here, Dev C++, has a little drop down for your compiler profile, different variants in how you want to compile your code. And currently, I've got this set to a 32-bit debug compilation profile. And what I want to focus on is that debug profile. So the thing is that usually asserts are something that you only rely on for in-house testing. And when you're doing in-house testing, you make what's called a debug build that includes all the assertions. Now, like I'm saying, if they're peppered all through all your functions beginning and end, that actually is a little bit of a burden on the CPU. You're checking this, you're checking that, you're checking the other thing, and you wind up burning quite a bit of time on the CPU, and it might slow your program down with all these maybe thousands and thousands of checks that it's doing with every single function call. So for release code that you're actually going to distribute to customers, you don't want that. You don't want your program slowed down like that. So what I can do on the day that I want to do that is I'm going to go to my drop down here, and instead of the debug version, I'm going to click on the release compiler profile. And I get a little warning box about, that's going to make something very different. You sure you want to do that? Yes. And so I'm going to have to rebuild all my program, which I'll do right here. So just rebuild with this new compiler profile. Notice that I'm not changing any code at all, but now when I run it, right, that assert just doesn't happen because it's not in the program. It didn't get compiled into the machine code. And val comes in as -8. Line 14 just doesn't exist in the machine code. You get to line 15 like normal, and you just print out value is -8. So asserts, if you're doing this, asserts aren't going to help you in release code. They're a debugging technique that I'm testing, and I get to a point where I'm confident that assertions just never get triggered. I'm never in a situation where my function precondition, postconditions are violated, and that's the point where I'm confident I can release this code to customers. There's no unexpected logic errors, and I might as well just strip the asserts out and make the program run faster. Now, how did it accomplish that? So in my IDE here, I'm going to click on Tools, Compiler Options. Okay, and so here I see the configurations for these different compiler options. Currently, I'm looking at the debug build, and you notice that this box right here doesn't have any additional switches, any additional commands being sent to the GCC compiler. Just everything that's on screen, all the code, it just gets compiled. But if I switch over to the release build, right, I've got this clicked off. I am adding an additional command to the compiler, specifically this switch for dn_debug, and what that stands for is define the variable no debug. Define the switch no debug. That's kind of like one of those if-def statements that we use for include guards around header files, and this specific preprocessor variable for no debug is built into the assert function. So when you define the no debug switch, the compiler sees that, and asserts just don't happen. Asserts are just not compiled into the code. Now, I will point out that this is something that I had to add to my release configuration, this -dn_debug switch, to make that happen and have the release remove the asserts. I'm a little bit surprised that Dev C++ doesn't have that in the configuration automatically. But if you want to do this, you have to add it. You have to go into the compiler options here for your release configuration and add the -dn_debug switch to make this happen. It really, this is what it's for. The only thing this switch does is remove assertions. It's part of standard ISO C++ and C for what it's worth. So I feel like this really ought to be a standard part of if you have a release configuration, this is what ought to be there, but you do have to add it yourself. And that's what asserts generally do. And next, I'm going to pull up a code file that I was working on recently. I was working on, I'll say, a simple AI for a fairly old naval war game about ships. And so what I'm looking at here is my implementation file for my ship class, for what it's worth. And this is one of the longer code files in this fairly simple program. It is about 750 lines long, for what it's worth. And you can see that it's including a bunch of other stuff that I wrote. The only standard library that I'm including here is actually the CAssert library, because that's built into a lot of my functions. So I'm just going to search for some places where I have assert statements that are maybe a little bit easier to explain. Maybe not that one or that one. But here I have a function that tries to repair a particular kind of damage on the ships every turn. This is called the evasion level, which is technically the real world speed is what it is. So ship takes damage, it slows down, but it has the opportunity to possibly repair it. So here's some math, right? There's a die roll, there's a table lookup. I'm trying to repair this particular type of damage. I'm going to log a message if that happens to keep track of what's happening. And I was worried that I might possibly screw up the math about repairing that damage. And the thing that wouldn't make sense is I should only be able to repair the damage down to 0. It wouldn't make sense to repair damage to an actual negative number, because then my ship would actually get faster than whatever it was in the first place. So I'm doing the math here, and the very last thing in the function, you might say it's my post condition, is that the damage level for this evasion shouldn't be any lower than 0. So at this point, I'm asserting that this damage level must be greater than or equal to 0 to make sense. If I screwed up the math while the program is running, it would hit that line and just stop it and tell me that I must have screwed something up. Now, fortunately, I didn't screw up the math of this, and this assertion has never failed. But when I was writing it the first time, I was giving myself a little bit of a safety net just in case I screwed it up the first time. What else? Okay, so here is a function that's figuring out how capable a particular ship is at searching the nearby sea, maybe for opponents. And I have a bunch of different types of ships in the game, and these are naval codes for it. So BB is a battleship, and CA is a heavy cruiser, and CV is an aircraft carrier, things like that. So different types of ships have, in this switch statement, have different search capacities that we're calling search strengths. And they also vary depending on whether you're in daytime versus nighttime, and whether you've set the ship on patrol to kind of get a broader search area versus not. So that's all here. But when I was writing this, I was a little bit worried that I might have missed one of the ship types, or thinking into the future, if at some point I add new ship types in the future, I gotta not forget to come in here and add another case statement to handle it. So just in case, either now or in the future, I forget to handle one of the ship types, my switch statement has a default. If I don't handle something, gets me down here. I do throw up a message, and then I just hit this assert statement. And of course, assert statements are always supposed to be true. So in addition to this message, just in case I happen to miss that, this assert statement on line 213 is guaranteed to just end the program. And I will definitely pay attention to that. So that'll definitely get my attention that I must have missed something, namely I forgot one of the ship types here. Now again, this has never been triggered. I didn't forget any of the ship types, but someday in the future, if I add a type and forget to come in here and add it, this will alert me very quickly about that. Let's see if there's another one here. So here is a function that reports on or actually sets the current position of the ship. And what happens is when the game is actually running, I don't want to do this. I only want to actually arbitrarily set the position when I'm putting the ship down on the game board right at the start of the game. It should never happen again. So what I'm doing here is the ship keeps a daily log of what it's done in the record keeping. And what I'm doing here is that if the game's underway and I have a couple of records, a couple of daily pages in the log, I should never call this function ever again. So what I'm doing here is that I'm asserting that we only call set position when the logbook is empty, before the game has begun. So I assert that. And if at some point I make some kind of mistake when I'm programming it, and I overlook that expectation, I call this function when the game's underway, that would be cheating. That would be like picking up the ship and just moving it to the other side of the ocean, which shouldn't happen. So if I forget about that someday in the future, call that function when the game's underway. That assertion there will prevent me from doing that and stop the program and alert me to the mistake that I've made in using this function. Okay, and you can see other examples. I've got it all through, maybe not every function, but a lot of my functions, you have an assert right at the start, like that, checking a precondition about how this function is supposed to be used. This function here is trying to move a ship on a particular turn, and before I can do that, I have to give orders to the ship about where it's supposed to go. So in this particular case, I have an assert statement that confirms that the ship actually has orders to follow on its movement. And if I forgot to do that in some other part of my system, again, the program will be ended and I'll be alerted immediately that somehow I screwed something up and I'm calling the movement function without actually giving the ship any orders. And that's what a lot of this stuff looks like. So have some asserts at the start of a function is pretty common. Have an assert at the end of a function is very common. It's so easy to do this, right? It's just a teeny little piece of code. And even if the vast majority of the assertions have never been triggered, well, that's giving me confidence. That's giving me confidence that I'm using the functions that I created in the way that I expect to. And if none of these assertions are being hit, I'm pretty confident that I don't have any bugs in my program. And here's another clever way that you can assert. So with this same naval game, I have a test driver, of course. And it's not the game application. It's a separate program that just tests that all my components and all my classes are working as expected. And this is something we talk about in class all the time. So what I have here is all the different parts of my game, the search board, the map, the ships, the pathfinder, all this stuff I have tests for to make sure that they're working properly. So that's a bunch of tests. I have it modularized into a bunch of different functions here, and they kind of go on for a ways. I'm just going to look at one. So here is the function that tests my distance calculator on the game board. And that's a non-trivial calculation. Finding the distance from one point to another is non-trivial because the game board isn't just a simple grid like a chessboard. The rows and the columns are offset like a wall of bricks, right? They're not at the same level on every row. Topologically, it's like the whole thing is all a bunch of hexagons because every space doesn't have 4 things next to it. It actually has 6 things next to it. So the math to calculate the number of spaces from one place to another is a little bit more complicated. So this is one of the first things I did when I wrote this, is I was a little worried I was going to screw up the math on calculating the distances. So this function here just tests the distance calculation from one space to a bunch of other spaces. And I make one space here that, for what it's worth, they're identified by a letter and a number. The row's the letter and the column's a number, kind of like a spreadsheet, frankly. And so I take this one anchor point and I check the distance to this other location on the map, F5. And notice what I'm doing here, the whole thing is all asserts. So instead of just calculating the distance and printing it to the screen, what I'm doing is that I'm looking at the actual physical map. That distance is supposed to be 5. And so I'm doing that calculation for a bunch of spaces near or further away from my anchor point. And what I'm doing here, I think, is a space that's up and to the left. And the next one is I'm testing a space that's up and to the right. And then here I'm testing something that I think is down and to the left. And then here, I guess I duplicated one of those actually. And then here, I think I'm doing one that's directly left. And here's one that's directly right. And one that's way down. And one that's further down. And of course, I always test the number 0. So I tested, like, if I check the distance from space K10 to K10 itself, that better be 0. That's a common place to have mistakes. So I was certain to do that. So what this buys me is that when I develop some code and I modify some stuff, I can run this test driver, and instead of having to read a bunch of distance calculations and manually confirm that they're right, the asserts just do it for me. So if everything's working correct and my math calculations are right all the time, it just runs through all these assert statements. It doesn't print anything on the screen until you get to this line here. It just prints out one thing, which is just saying your tests are successful. Good. If I did screw anything up, I'm just going to see one thing on screen of this assert statement failed and the program's over. So I never have to read a bunch of stuff from this test. It's always either just everything's good or something is bad. And it's kind of like getting a red light or a green light about whether my components are successful. So think about that. You might start making all of your test drivers basically all a bunch of asserts. And then it becomes very convenient to rerun your test driver when you're developing, when you're modifying, when you're expanding some kind of class objects. And you can just very quickly see a yes or a no. Is everything working properly? Now, again, you have to put some thought into developing your tests of like, what kind of values can I get back to test? And again, what I've done here is test something up and down and left and right and closer and further away and a big number and also 0. And by putting a little bit more thought into your test cases, the asserts make it so much easier to have more test cases. And instead of committing to reading a bunch of stuff manually again, you don't want to have to repeatedly manually read a bunch of test cases. You should get the computer to do it for you. And the easiest possible way to do this is to use asserts. So for many of us, our test drivers look like that. They're basically a whole bunch of asserts with one single cout statement at the end that basically says the tests were successful. Everything's good. Go back to work. So hopefully you agree that asserts are very easy to use, right? It just looks like a one-line function call. They're extremely useful in a bunch of circumstances. So you can put them all through all of your implementation code anytime you have a precondition or a postcondition. Like it takes like almost a single second to type in the asserts and have the program actually confirming that everything's working all the time. And you can make your test drivers like this. And if you're worried about the extra time on the CPU, you can make a release compilation that just strips out all the asserts, and then your program is super blazingly fast for your customers when you release it. So asserts are really essential fundamental tool. So I hope that you'll start using that in your programming code. If you're working in C, same thing. If you're working in Java, also available. So you can use it in practically any language. And I hope that you'll be using that and you'll be looking for the next video on another topic, and I'll see you then.